Hi, I am Himani Deshpande from the HCID lab at Texas A&M University, and I am presenting EscapeLoom, Fabricating New Affordances for Hand Weaving, a paper co-authored with Dr. Haruki Takahashi and Dr. Jeeun Kim. In this paper, we'll look at how we can leverage material properties and fabricated tools to support hand weaving activities. We were inspired by the works that looked at building computational tools for craft-oriented fabrication, tools for maker-oriented learning, and works that explored material properties to enable different kinds of fabrication. To investigate the design space and requirements of designing fabricated aids for hand weaving, we conducted a formative study with novice weavers. Through this formative study, we observed that participants had a hard time synchronizing their weaving process and following the printed pattern draft. One participant also tried to generate a complex pattern that embedded an image of a cartoon, as can be seen in the image. Feedback from participants pointed at a need for feasibly adding complex images to their patterns. From participant feedback, we also understood that they would like to weave something that can be used in real life as compared to something abstract as a piece of woven fabric. Through this workshop, we derived our 3 design guidelines. First, the design should enable ease of learning, aiding a gradual understanding of the weaving process through tangible experiences. Second, the design must address the translation gap between a pattern draft and the actual weave. And lastly, the new user experience should empower creative exploration with weaving of practical usable objects. Following these guidelines, we propose 3 techniques for creating 3D printed aids for hand weaving as part of our tool, EscapeLoom. First, we provide water-soluble looms as coded guides to eliminate weave draft synchronization and facilitate learning of the weaving process. Second, we provide warps as pattern generators to enable further creative exploration and integrate the concept of a loom within the final woven usable artifact. Lastly, we also support global geometry to enable weaving of practical artifacts and further creative exploration. I will now briefly explain the techniques. For water-soluble coded guides, we use polyvinyl alcohol or PVA. The shape-coded loom has circles and squares to indicate the position of warps and wefts respectively. The holes outlining the pattern facilitate tying off the yarn in place. Users can create their own pattern using our tool or choose one from our pattern library. They can 3D print their guide, follow the shape codes, weave their pattern, dissolve the loom in water, and produce their woven pattern. The second technique looks into how we can facilitate different shapes of looms as well as warps. For shaped warps, we use thermoplastic polyurethane or TPU, which is a flexible filament. In our tool, users can import SVG files of their drawings and convert them into TPU looms. Our tool thus enables using drawings to decide loom shape. Added to that, users can choose the shape of warps that will be filled in the looms. Shaped warps from our pattern library enable creation of curvy, wavy, and zigzag patterns with a simple plain weave. Users can hence weave personalized usable artifacts such as coasters, necklaces, as well as masks. In the last technique, we go one step further in creating usable artifacts by introducing global rigid geometry with soft woven parts. Users can import 3D models into our tool, divide it into sections, select sections that will be woven, and select assembly techniques for assembling the final artifact. This process enables weaving usable objects such as a lampshade and can also facilitate scaled rapid prototyping of large furniture items like a chair. To briefly outline what our tool supports, EscapeLoom supports material inclusivity such that different loom parameters are customizable based on the desired pattern and material used. Another facilitation is in situ improvisation brought about by material properties. For example, cutting and joining different PVA and TPU looms to create unique patterns. In terms of future implications, we hope our tool can help the maker and handicraft community in expanding their product portfolio. Our techniques can potentially be used to generate computational toolkits for tangible learning for kids and adults alike to improve different skills. Another possible avenue for this work is supporting upcycling discarded objects as looms or yarns, making the process sustainable and further augmenting the design space of hand weaving. Thank you for listening.